I'll do the pizza one tomorrow. That one is pretty good too. Finding the equation of the axis of symmetry. Since the parabola is symmetric, since the parabola is symmetric, points on either leg are, here's the word of the day, guys, equidistant. So meaning they're always the same distance apart from the center, from the axis of symmetry. Let's put down center. Right? From the center. If you're given 2 points that have the same y value, that's probably worth highlighting the same y value. Two points that have the same y value, meaning they have the same height. We can find the axis of symmetry using the following formula. So AOS, we know it's an equation, and that equation is x is equal to, it's usually a number, okay? But if you don't know what that number is, we can take x1 and add x2, x sub 2. Make sure you put brackets around it. Then we divide that in half to get the middle. This is kind of like finding the average between the two. Okay? Where x1, sorry, x, let's start with x. X is the axis of symmetry. X1 is the x value of first point. X2, x value of second point. And I haven't done this before, but maybe you want to think of it this way. If you had a parabola that went like this, okay, you should know by now that there is a way to cut this in exactly half. Okay. So if there's a point here, that would be, we would consider that x1, like the x value of that point. And then there's one that's right across from it on the other side. That is what we call x2. So if you were to add these two x values up and divide it in half, you get what we call the x, which is the axis of symmetry. So this basically summarizes what I'm trying to tell you here. Okay. So let's put this to practice, right? Determine the equation of the axis of symmetry of the parabola below. Okay? Use both sets of points. We're just going to show that it doesn't matter which two you use, as long as they're opposite each other. So please put some arrowheads here. It bothers me. But when I made this, I used Desmos. I don't know if you've ever heard of Desmos, but it's a neat graphing. Yeah, it's an online graphing calculator. You have an app as well for it. So let's consider these two here. First and foremost, you need to understand that they are right across each other. They're at the same height. At the same height. And technically, we know that the vertex is right here. That's the lowest point in this case. I'm going to use a ruler and just say, technically, that is the point that cuts this parabola in half. And that's an imaginary line. Okay. This is what we call the AOS, the axis of symmetry. think of axes, right? In the plane, there's the x-axis, the y-axis. This is the axis of symmetry. It's the line, like an imaginary line that splits it in half. Okay. Can we just look at the graph and know what the axis of symmetry is? It is technically 2, correct? By observation, because the vertex is 2 in terms of the x value. But let's assume we don't know that. So the axis of symmetry would be found the following way. Let's call this x1 here. And let's call this one x2. So we have -2 plus 6, and we divide that in half. -2 plus 6 gets you 4. 4 divided by 2, and that gives you 2. Therefore, x is equal to 2 is the equation of the axis of symmetry. Okay, so that is the equation here. So we actually knew that already because I gave you that. Or we could use these 2 points. They're also right across each other. What's so special about this point right here? What do we call this one? Origin is down here. This one is the y-intercept, right? So sometimes a y-intercept is also in the mix. Just be comfortable with that. So we can call this x1 and this x2. So let's say we use these points that are right across from each other. We could go 0 plus 4, right? 0 here, 4 there. You add it up, you get 4. 4 divided by 2 is still 2. Therefore, x is equal to 2 is the axis of symmetry. I 99% of the time I do not give you a graph. Okay, I just did it here to show you, okay, that's what's happening. One thing I also want you to observe is if this is 2, you're paying attention to this one, right? How many units did I travel to get to the right leg? Let's count. 1, 2, 3, 4, correct? This is 4 units. How many do you think I'll have to travel to go to the left leg? 1, 2, 3, 4. Okay, that's something I need you to also be aware of. That's the equidistant part. Like from the center, you're 4 to this, 4 to that, okay, at that height. If you were to consider these 2 points, it's 2 units to the right, 2 units to the left, but it doesn't matter where you are on this graph. There's always 2 points that are exactly the same distance to the center, right? And so that's why this works, okay? So practically speaking, this is what this would be a 1 marker right here. I could just say calculate the axis of symmetry given the following 2 points. You should immediately recognize that they have the same height. Same height. I will highlight that with the same color. So that's perfect, because that means that I can call this x1, the -4, and I can call the 5 x2. So all I would want you to know really is go to your study sheet, look up this formula right here. And so axis of symmetry would be -4 plus 5 over 2. -4 plus 5 is just +1 over 2. And that's your axis of symmetry. You can go decimal if you'd like. So just make sure you state it like this, because it's an equation. It's not just a point. It's not a point. It's a line. Okay. This one I'll leave it up to you. You could figure that one out I'll just do this one here. I think we've got enough of that. It would be just mental math here. 3 and 7 is 10. 10 divided by 2, 5. So the axis of symmetry, right, goes through 5. X. What does this tell us, though, folks? If I ever wanted the vertex, this is important, actually. You would have to agree with me that I technically know already the x value of the vertex at this point. By finding the axis of symmetry, you technically know the x value of the vertex. But we don't know this. Right?
Sorry for the interruption again. I would just
Interrupted a little bit here. So I just want you to know that technically you have partial information of the vertex. We don't know the y, but we do know the x value. So I need you to know that, okay? Let's keep going. Page 13. And then I want you to practice a few more graphing questions, okay? I should add my videos like with a warning, graphic content, right? Anyways, finding a missing x value using the axis of symmetry / vertex. Okay, so here we wrap it all up. So you have a point, another point, and the vertex. Okay, you want to figure out this point right here. So you got to think of it as this. What is that? That is my axis of symmetry. And the axis of symmetry, therefore, is x is equal to 6. And these are at the same height. Do you see that? So I'm going to use this formula to see if I can solve for a missing value there. I already know what x is, correct? In this case, I'm not trying to find the axis of symmetry. I already know what it is. So I'm going to plug that in there. Okay, so this would be 6 is equal to, what about the x1 and the x2? Yeah, I'm going to go up here and make x1 be 3. So I'm going to call this x1. And the question mark is going to be x2. That's the one I don't know. So you almost want to imagine there are 2 points that are across each other. We just don't know this x value here. So we're going to go 3 plus x2 over 2. And yes, you have to do some algebra here. We want to slowly isolate the variable in question. So we multiply both sides by 2. Right? That gets rid of the 2's here. So 2 times 6 is 12. You're left with 3 plus x2. Now we would subtract the 3 or bring the 3 over. If the 3 comes over, it's 12 minus 3 is equal to x2. So that leaves us with 9 is equal to x2. Okay? So that point, therefore, it's that point that's across the 3, 5, it's going to be 9, 5. Check. Did you do this right? 9 plus 3 is what? 12. 12 divided by 2? 6. Okay. We're good. Okay? So you kind of just... It's all about the axis of symmetry here. I just want you to think about it. You know what? I've had students do this. They imagine this to be 3, 5 here. And this is something 5. This is question mark 5, and the vertex is 6, negative 10 here. And they kind of figure it out this way. They're like, okay, this is halfway here. So how many units is it from here to there? To go from 6 back to 3, that's 3 units, right? Therefore, from here to there must be 3 units as well. So what's 6 plus 3? 9. So no matter which way you think about it, you're going to get there. Okay. Let's keep going. I told you this is a bit random, and it's not going to be the last time you'll see it, but I don't know where else to put this. Okay. It doesn't have like a specific lesson attached to it. Next, given f of x is this, okay? And I know it looks ugly, but don't worry, you have your calculator, worst case scenario. Describe the direction of the opening, the width, the y-intercept, and the y-intercept of the parabola. First of all, we know this is in general form. How do I know that? No brackets. It's not a very scientific way to say it, but it is. It's no brackets, it's general form. Okay? The direction of the opening. A is negative, so it's going to open down. Okay? So that's that. What's the width? Narrow, wide, normal. It's definitely not normal. It's definitely not narrow, because narrow is greater than 1. So this is wide. Okay? A is between 0 and 1. And the y-intercept is going to be 0. It's the c value, right? And the c is 0 here. So it's actually the origin, aka origin. Okay? It's also known as the origin. So maybe just for your notes here, I'm going to say that, right? We added that, and then we just came up with that value there. Two more questions, and then I'll ask you to do some more graphing and using your calculator, okay? Determine f of 3 and f of negative 4. What is that word there? You almost forgot about it. Algebraically. It means you have to show your steps. You have to show your work. You can't just use your calculator. What are you finding? Explain. Okay? So what you want to do is, you want to go f of 3, and this equation that you were given here, you want to substitute 3 wherever there's an x. And it doesn't have to be x, it could be any variable, right? But we put 3 in there, we square it, and we go plus 12.5 times 3 again. Okay? Break this down. So grab your calculator. I go second quit to go to your home screen. And then you go negative. Okay, leading coefficient. I'm going to put an arrow there and make sure you use negative for that one. Negative 0.02, right, times 3 squared. Actually, the squared is outside the bracket. That is actually important, just in case it's going to be negative. Okay. Uh-oh, what happened there? Sometimes it's weird. I'm just going to go delete. And delete. Let's try this one more time. Squared. I can do this. I can do this. There we go. Negative 0.18 plus, you're going to go 12.5 times 3. That's 37.5. And now just use your calculator. I'm going to copy paste the 0.18, and I'm going to add, copy paste the 37.5, so you're left with 37.32. That is f of 3, folks. What have you really found? You found a point on the parabola, which is what? X is equal to 3. And the y value is 37.32. That's what you've just found. Let me zoom into that a little bit or bring it up, because some of you need to make sure you have this down. Okay. Can you practice this with f of -4 just now before we move on? Go f of -4 and do exactly what I just did here. See what you get on your calculator. Yeah, I'm just gonna go. This is probably a little longer. You don't, as long as you show me a couple of lines, I'm gonna be fine with that. Okay. How would you be able to find these values if you had to use your calculator and the graph is on your screen? What would you do? If I give you an x value, you go second trace value, x is equal to 3, boom, you're gonna get a coordinate that matches the 37.32. Same with the -4. It would match that, right? Done?
No, I'll do the line is really big, so I'll do it next time so that it's fair.
Okay. Last but not least, and then you have the rest of the class to just do your work, okay? Some of you might have to leave. Please know this one, okay? Given y is this, state the values of a, b, and c. All you have to do is this, folks. A is what? -3.75, but not the x, okay? Some folks would, oh, sorry. This is wrong, actually. What's wrong with this one?
It's not squared.
So a is in front of the x squared term, correct? This is a. So sorry about that. Okay, YouTubers, ignore what just happened, okay? So that's going to be 74.3, my bad. Maybe we did that to check if you're paying attention. So a is 74.3, not the x squared, it's just the value in front of the x squared, which is the leading coefficient. Let's write that down, leading coefficient. B is -3.75, and C is -345. Okay? Homework. All I want you to do is, I want you to go to page 29. Let me just double check if I got that right. 29 to 30. Okay? Page 29 to 30. You need to use your calculator and graph. Graph parabolas. Okay? Very important. So make sure you add that to your homework, okay? I will post a key to that as well.